Hello, welcome back to the Remote Sensing Cookbook. In today's video, we're going to walk through calculating a normalized difference vegetation index raster, which is commonly known as NDVI, and we'll be calculating normalized difference snow index, which is commonly known as an NDSI. These calculations will be completed within ArcGIS Pro, and we will be using Sentinel-2 imagery. Before we begin, it's important to note that the data for this demonstration was downloaded from Copernicus, and different locations were selected for each calculation. For the NDVI calculation, the Amazon rainforest in Brazil was selected, and for the NDSI calculation, the Northwest Territories in Canada was chosen. To begin, we'll first start with calculating NDVI, which is a way to measure the health and density of vegetation. When in ArcGIS, make sure that you have correctly connected the Sentinel-2 data from your system to ArcGIS. Here, under the Catalog heading, you can see that we have connected the data and the files were renamed. Let's go ahead and select the NDVI folder. Within the folder, we will need to navigate to find the 20-meter resolution images, which contain bands 1 through 12. Since we are trying to complete an NDVI calculation, we will need bands 8 and 4, which are near-infrared red and red, respectively. These two bands will be added to our workstation. The base map will adjust to the location of the bands. Likewise, the bands can also now be seen under the Content heading. The next step is to complete the calculation for NDVI. This can be completed by going to the Analysis tab within the ribbon and selecting the Tool feature. When selecting the Tool feature, the Geoprocessing Tool feature will appear, and within the Geoprocessing tool, we will search for the raster calculator. We'll go ahead and select the first option. Within the raster calculator, we must enter the query to complete the calculation for NDVI. This can be created by entering the following query. We enter the float function before each raster expression because if we don't, ArcGIS will do integer division and remove decimals, thus creating incorrect results. Once this expression is entered, the next step is to run the function. Once the function is successfully run, a new raster will display under the Content tab. Likewise, the grayscale color ramp makes it difficult to identify vegetation, so we'll go into the symbology and select a different color ramp. And there you are, you have yourself an NDVI raster. Based on our color ramp selection, the following can be determined. Red-orange areas equal low NDVI, likely bare soil, urban, or stressed vegetation. Yellow-green areas mean medium NDVI, moderate vegetation health. And then dark green areas equal high NDVI, dense, healthy vegetation. Next, let's try NDSI. To begin, let's ensure we have correctly connected the Sentinel-2 data to ArcGIS. Once we can determine it is correctly connected, let's go through the NDSI folder with Sentinel-2 data and locate the 20-meter resolution imagery. Similar to NDVI, all 12 bands can be seen here, but since we're trying to complete NDSI, we'll only need bands 3 and 11, which are green and shortwave infrared spectral bands, respectively. Once we've located these bands, let's add them to our base map. Similarly to NDVI, we will go into the Analysis tab on the top ribbon and select the Tool feature, which will promote the Geoprocessing tool. We'll type Raster Calculator and select the first option. Within the Raster Calculator, we will need to enter the query to complete the NDSI calculation. Once this is completed, the next step is to run the function. Once the function is successfully run, a new raster will display under the Content tab. Likewise, the grayscale color ramp makes it difficult to identify features again, so we'll go into the symbology and select a different color ramp. There you are, you have yourself an NDSI raster. Based on our color ramp selection, the following can be determined. Blue to white yellow scale means this is a common choice for snow indices. Brighter areas, white yellowish, likely represent higher NDSI values, consistent with snow cover. And darker blue areas will likely represent lower NDSI values, non-snow surfaces such as vegetation, rock, or water. Thanks for watching this tutorial. Stay tuned for other remote sensing updates and how-tos. Also, reach out to us through our website, linked below, to submit requests and post questions on our forum. Bye!